Here's another example. Suppose we have a normal distribution of IQ scores with population mean mu equal to 100 and population standard deviation sigma equal to 15. What is the probability of scoring between 90 and 110? So let's go ahead and sketch this distribution out. So here is mu 100, and let's do 85, which is one standard deviation below, and 115, which is one standard deviation above. And we're looking for the probability of scoring between 90, which is going to be about right here, and about right here for 110. Whoops, 110. So we are going to be looking for this area right in the middle here, right? So we're going to be looking in column D when we're looking at a unit normal table, mean to z's, okay? So we're looking for the probability that x is greater than 90 but less than 110, right? And remember, here is our z-score formula, which is x minus mu divided by sigma. Now, we have two scores, so we're going to have to come up with two z-scores, right? So for each x value, we have to find that z-score that corresponds to that x value. So let's go ahead and do the first one, which is 90 minus 100 divided by 15, which is equal to negative 10 over 15, which is equal to negative 0.666 in perpetuity. And then the second z-score, again, x minus mu divided by sigma, which is equal to 110 minus 100 over 15, which is equal to positive 10 over 15, which is equal to positive 0.666. So we're actually looking for z's probability of negative 0.67, remember we have to round up, greater than z, less than positive 0.67. All right, so now we get to look up these z-scores in the unit normal table. And we're going to be looking for column D, okay? So column D, 0.667, 667, which is right over here, right? So 0.2486. So basically, this area is 0.2486, and this area is 0.2486. So what we need to do in order to find the total area is we're going to need to add these two areas together. And this is equal to 0.4972. So the probability of scoring between 90 and 110 is approximately 0.4972 or 0.497. So there is our answer. Now let's look at finding the x value if we know the probability. In this case, we start with the probability and find the z-score in the table. Once we have the z-score, we can use the z-score formula to solve for x to get the x value or raw score corresponding to that z-score. So here's the best way to find a z-score from a probability. Step 1, sketch the normal distribution. Step 2, shade the region corresponding to the required probability. Step 3, locate that probability in the correct column of the table. Step 4, label the edge of the shaded region with the z-score. And finally, step 5, calculate the corresponding raw score x. So here's an example. Suppose we have a normal distribution of x scores with population mean mu equal to 100 and population standard deviation sigma equal to 15. What IQ score do you need to have to be in the top 5% of the population? So let's go ahead and sketch this out. And let's sketch out .05. This would be 5%, and we're looking for z, right? We don't know what z is, so the area is 5% of 0.05. So we need to go to the table, the unit normal table, and it's in the tail, so column C, and we need to look probabilities. We're going to need to look in the actual probabilities. So we need to keep going down until we get close to 0.05. Here we go. Here's 0.05, 0.0495. So really 0.05 is between the z-score of 1.64 and 1.65. We're going to use 1.65 as our z-score. So z-score is 1.65. That corresponds to an area of 5%. Now to find the raw score, remember that it's x is equal to mu plus z times sigma. So x is equal to 100 plus 1.65 times 15. So x is equal to 100 plus 24.75. So the IQ score that we need to have is 124.75. So that is the lowest IQ score that would put us in the top 5% of the population. And that is our final answer. Another way you can use the unit normal table is to find percentile ranks. Here's an example. Again, we're going to use the normal distribution of IQ scores with population mean equal to 100 and population standard deviation sigma equal to 15. What is your percentile rank if you have an IQ of 130? So again, we're going to sketch this out. And remember that percentile ranks has to do with, here's 100, sorry. Percentile ranks, so here's 115, 130. Sorry, I can't do two things at once. So here we go. So 115 is one standard deviation, 130 is two standard deviations away from the mean, right? So what we're looking for in percentile ranks is basically the percentage of individuals who scored lower than 130. And this, by the way, is the body. So now we're looking for the body of the distribution, right? So we're looking for the probability of x less than 130, right? So we need to standardize this. So z is equal to x minus mu divided by this sigma, right? So x is 130 minus 100 over 15, which gives us 30 divided by 15, which is equal to 2 standard deviations, right? So we go to the unit normal table. We look for a z of 2, which is right here. 2, proportion in the body, 0.9772. So let's go back to, so our percentile, so P is equal to 0.9772. So our percentile rank is equal to 97.72. So a score, an IQ score of 130 puts us in the 97.7th percentile rank. And there's our answer.